This video is a demonstration of the Spitzer Heritage Archive Precovery search. When you first load the SHA, you're dropped into a results page, and the two tabs that you get by default are Search by Position and Search by Solar System Target. But what you actually want is the Precovery search. What this does is, given the orbital parameters that you put in, it tries to figure out if Spitzer serendipitously observed the object. So you first need to put in the name of the object. You need to put in either the NAIF ID or the name, and then you have to pick the object from the list. You actually have to pick the object, even if you've already put in the NAIF ID. Everything is tied back to the NAIF ID, so you need to pick the object off the list, even if there's only one object on the list. Alternatively, you can put in a one-line MPC string, or you can manually put in the orbital elements. But I'm going to go with this object name because I know what the results are going to be. Then you need to put in the time baseline over which you want to do the calculation. You don't want this time baseline to be too long because otherwise it will take forever to run. Then go ahead and search. The results that it comes back with look something like this. You can see that in the data coverage tab here, it's calculated the orbit. I only asked it to calculate the orbit over about 7 months. So it doesn't have a very long orbital path. You can see that it curls over here, but you can see that it's calculated the individual parts of the orbit here. But it did find some frames. And if we go in here and zoom in, you can see the individual epochs that it calculated here, and then these are the frames that it found that overlapped the position. If I click on the individual frames, it highlights it in the table, and if I click on the frames in the table, it highlights it in the image. If I go to Data Preview, these are the individual frames that it found. The reticle, which may be hard to see in some cases, is the calculated position of the object, and you can see that there might be something there in some of those individual frames at least. You can see they're actually coming from different wavelengths. So those are 70 micron frames. This frame, let's see which one this one is. If we go here, let's see, that one is a MIPS 24 frame. So we've got some MIPS 24 frames in which it's likely that it's detected, but I don't think it's going to be detected at this 160 micron frame, and it's probably unlikely to be detected at 70 micron frames. But it seems like it's probably detected at the 24 micron frames. So this algorithm isn't telling you for sure that the source is detected. It's just telling you that, hey, the corners of this frame overlap the calculated position of this object. When you decide that you want individual frames, you can select all of them or select individual ones and then prepare download, and then you're off and running.